Today we're going to be talking about proportions in similar triangles, and we're going to begin with the triangle proportionality theorem. This says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So if we have this particular diagram here, where we have this triangle and we have a line parallel to one side of the triangle running through it, and it creates this diagram. If TU is parallel to QS, what this means is that the proportion RT over TQ is equal to RU over US. Now, moving on. Here's another statement of proportionality. Let's say that we had three parallel lines here. So we've got UV, WX, and YZ that are all parallel to each other. And notice that they're cut by the transversals L and M. What this means is the ratio of UW to WY is equal to the ratio of VX to XZ. Really similar to the triangle proportionality theorem we saw on the last page. Here's a ray bisecting an angle of a triangle theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Now what this means is if you have this diagram and you're given that ray CD bisects angle ACB, then the ratio of AD to DB is equal to the ratio of CA to CB. That's probably not quite as intuitive as the others that we've looked at. But again, the ratio of AD to DB is equal to the ratio of CA to CB. Okay? Now this takes some practice. Don't get discouraged if you don't understand this right off. We just need to do some work with this to make it make a little more sense. So let's take a look here. Number one, we are given this proportion or this diagram with some, and we're going to be making a proportion from it. We want to find x. All right, well, we have these two sides, or one side of the triangle is parallel to a line going through it. And so we can write this proportion. Remember, this goes back to the, let's see, the triangle proportionality theorem. So we're going to say the ratio of 3 over 8 is equal to x over 12. So we're making a proportion here. So what we have to do is cross multiply. So let's do that. So 3 times 12 is 36. 36 equals 8x. So we're going to divide everything by 8. And we get the x is equal to 4.5. All right. Now this is very similar. The next one, number 2, is similar to the previous one. We're given that these three lines are parallel, cut by the two transversals. So we have 9 over 15 is equal to 11 over x. And we want to cross multiply. So we have 9x is equal to 11 times 15, which is 165. Now divide everything by 9 to get x alone. And 165 divided by 9 gives us 18 1/3, or 18.3 with a 3 repeating. Okay, so once we make our proportion, we're all set to go ahead and solve. Now let's take a look at this one. Again, it's the triangle proportionality theorem. Just what we learned before, the triangles just turned in a different direction. So we know that the ratio of 56 over 21 is equal to 48 over x. And let's cross multiply. So we have 56 times x is 56x, and 21 times 48 gives us 1008. We want to divide each side by 56. And we get that 1008 divided by 56 is 18. So our missing number is 18. Now, moving on to this next one. This is the ray bisecting an angle of a triangle theorem. So we want to set up our proportion. We know that x over 8.75 is equal to 9 over 15. And let's go ahead and cross multiply. X times 15 is 15x. And then we have to say 8.75 times 9, which gives us 78.75. We need to divide everything by 15. And we end up with x is equal to 5.25. Now, we're going to be doing a lot more practice in class, so don't get discouraged if you're not quite sure how some of these are set up. We're going to be practicing. I'll be there to help you. Write down your questions and bring them with you to class so that we can work on those first thing. Thank you for joining me.